If you are reading this message, then you know the Terminators have taken over. We are the Resistance. Our leader is John Connor. We sent Kyle back in time to warn his mother, Sarah Connor, about the Judgment Day. And I'm just kidding, guys. We're doing pre-calc today. So it's going to be business as usual. I'm going to do classwork, and then we're going to have a test. I know it seems like, what, we're simplifying fractions? No. We're going back to limits, but I'm going to give you the derivative as a superpower to help limits get evaluated a lot easier. So this is kind of like going back to Super Mario Brothers in level 1. Let's say you want to get all the hidden coins. You can use the power-up from a future level to get back to the first level. So let's just go back and let's look at simplifying a fraction. 10 over 20. You and I both know how to simplify this fraction using the greatest common factor. The biggest number I can divide out of 10 and 20 is in fact 10. So why don't I literally just divide the top and bottom by 10, and I will get 1 over 2, or 1/2. But let's examine what it is we're actually doing when we're simplifying a fraction. Technically what we're doing is we're factoring the numerator and the denominator and canceling out 1 over 1. So let's just say I break this out. I don't know what divides out of 10 and 20. Let's just pretend it's 2. So 2 times 5 is 10, and 2 times 10 is 20. Can we break this up even more? 2 times 5 can't be broken up. Let's just say we do 2 times 5 times 2, because 10 is 2 times 5. So literally what we're doing is we're canceling out prime factors. 2 cancels out with 2, and 5 cancels out with 5. There's no factor on top, so we can automatically put a 1 up on top. So 2 times 5 times 1 over 2 times 5 times 2. Therefore, this gets simplified to become 1/2. Now try that with 24 over 30. Well, let's just go back to elementary school and say the greatest common factor of 24 and 30 is 6. So 24 divided by 6, 30 divided by 6, we get 4 over 5. If only that were so easy in calculus, what we're about to do. Well, let's just break it down because I like to do a miniature model before we tackle the big scale. So let's take a look at this. 24 can be broken down. I like 6 times 4. 30 can be broken down into, let's go with 3 times 10. Is there anything to cancel out right now? Well, let's break it down into primes. 6 can be broken down into 3 times 2. 4 can be broken down into 2 times 2. 3 is prime, that cannot be broken down. And 10 can be broken down into 2 times 5. Now let's look at what cancels out. Hey, I see a 3 divided by 3, that becomes 1, so that cancels out. A 2 divided by 2 can't, what am I thinking? Did I just mess up? 3 times 2, 3 times 2, no. Oh, no, I didn't mess up. I thought I forgot to put something on down there. See, even I with a bachelor's degree tried to go, this is easy, no big deal. And then even I was like, wait, do I know? Do I forget how to do this? And you know, I get paid to be here, you know. 2 divided by 2 cancels out to form 1. So 2 times 2 is 4, and that becomes 4/5. So what we're doing is we are taking the right side and applying it to calculus. Okay, just making sure that the camera can see both methods. I like it. Okay, cool. All right, so now let's go back to a topic that we saw in Algebra 2, where we're simplifying a rational expression. So simplify, not the fraction, but a rational expression. which is a fancy way of saying a fraction with x in it. Okay? Simplify the rational expression. Okay? So the key to doing this is to factor the top and factor the bottom and simplify the prime factors. Let's take, for example, 4x minus 4 over 6x minus 20. 6x minus 20. So you want 6x minus. Can't write. 6x minus 24. Okay? So let's factor out on the top. Well, the greatest common factor of 4x and 4 would be 4. So what I'm going to do is factor out the 4 on the top. 4 times what is 4x? That'd be x. 4 times what is negative 4? That would be negative 1. 6 times, so now I'm going to factor, what is the greatest common factor of 6 and 24? That would be 6. 6 times what is 6x? That would be x. 6 times what is negative 24? That would be minus 4. And there's nothing on the top and bottom that I can cancel out, but just for the sake of being neat, I can break 4 and 6 by factoring out a 2. So I'm left with x minus 1 on the top, 2 times 3 times x minus 4 on the bottom. Can anything cancel out? Yes, a pair of 2's. A 2 on the top and a 2 on the bottom. That gets me 2 times x minus 1 over 3 times x minus 4. Okay? Okay. Now, on the second problem, let's see if we can do this. 7x minus 21 over 9x minus 27. Okay, so this one's going to be a little bit different. Well, can I factor anything on the top? Looking at 7x minus 21, they have a greatest common factor of 7. So I'm going to factor out the 7. 7 times what is 7x? 7 times x is 7x. 7 times what is negative 21? 7 times negative 3 is negative 21. So that factors out into 7 times x minus 3. Looking at the bottom, do 9x and negative 27 have a common factor? Yes. Let's go with 9. 9 times the quantity, 9 times what is 9x? That would be 9 times x. 9 times what is negative 27? That would be negative 3. Is there anything that can cancel out here? On the top and bottom, it looks like we have a factor of x minus 3. So I'm going to cancel out x minus 3 on the top and bottom, leaving me with just 7/9. That's very neat. Okay, all good? Okay. Let's do 6 more problems. Okay. This time, number 3. 6x cubed plus 42x squared over 2x squared plus 26x plus 84. Okay, a lot going on here. Once again, my first plan of attack is to factor the top and factor the bottom by looking for a GCF. In this case, I'm looking at 6x cubed and 42x squared. Do they have any factor in common? Well, 6 and 42 have a 6 in common. X cubed and x squared have at least an x squared in common. So I'm going to factor out 6x squared. 6x squared times what is 6x cubed? It's like Dora the Explorer, isn't it? Just me staring at the camera. X, exactly. 6x squared times what is 42x squared? Swipe or no swiping. 6x squared times 7 would be 42x squared. Now let's take a look at the bottom. Once again, can I factor something out from all three? Yes, I can factor out a 2. So if I factor out a 2 from 2x squared, 2 times x squared is 2x squared. Let me just erase that because I think I'm going to need more space. 2 times what is 26x? That'd be 13x. All right? And 2 factored out, 84 factoring out a 2, that would be 42. So my question then is the bottom completely factored? You guys remember, I told you never ever forget how to factor because this stuff is super helpful. Well, let's find out. Well, I can't go wrong. Can I factor out the top? I mean, the only thing I can really think of is just to separate the 6 and the x squared. But we can always just put it back together if we don't really need it. So 6 and the x squared and the x plus 7. And then there's the 2 right there, right? And now, what do we need to do? Remember, we need to factor a quadratic trinomial by figuring out what two numbers multiply to 42 and add to 13. You've got to know how to factor to pass Calc 1. Two numbers that multiply to 42 and add to 14, well, it's going to be a positive and positive combination. Well, you guys complete the table. Pause the video if you need to complete this table. Okay? So we go through the gauntlet. We try 1 and 42, 2 and 21, 3 and 14. 42 divided by 4 is a decimal. 42 divided by 5 is a decimal. 6 times 7, but 6 plus 7 is the winner. So therefore, this becomes x plus 6 times x plus 7. And now I'm going to factor even more because I notice I factored out this 2. I'm going to break this up into 2 times 3 times x squared times x plus 7. All that over 2 times x plus 6, x plus 7. So now I'm going to cancel as I like. The 2 cancels out with the 2. Any other factors that can cancel out? Yeah, the x plus 7 is going to cancel out with the x plus 7. Therefore, the final simplified version of this rational function is 3x squared over x plus 6. Okay. All right, moving on to problem number 4. Again, you can pause the video as you see fit. Okay. All right, number 4. X squared plus 8x plus 12 over x squared plus 3x minus 18. When you're done with that, I'll give you number 5 right here. X squared minus 7x minus 30 over x squared minus 5x minus 24. Okay. Please attempt this independently. Please pause the video if you need more time. Okay, moving on. So my first move when simplifying a rational expression, can I take a GCF out of x squared, 8x, and 12? Not quite. So I need to get creative and factor the quadratic trinomial. So on the top, I need to figure out what multiplies to 12 and adds to 8. Luckily, this is a positive combination. So you run the gauntlet, 1 and 12, 2 and 6, hey, we win. So this factors into x plus 2 times x plus 6. Now we have to factor the bottom. We have to figure out what two numbers multiply to negative 18 and add to 3. Positive 3, rather. So we look at this and we run the gauntlet. Well, if it multiplies to a negative number, that means that the combination has to be one positive, one negative. So one positive, one negative, and the dominant of the two factors needs to be a stronger positive. So I'm going to go with 1 and negative 8. No, the other way around. Negative 1 and positive 18. So negative 1, positive 18, that doesn't work. Negative 2, positive 9, that doesn't work. Negative 3, positive 6, we have a winner. So the bottom becomes x minus 3 times x plus 6. Now, I look, can I factor anything else out? No. So let's cancel something out. Is there a factor on here that I can cancel out? Yes. The x plus 6 cancels out with the x plus 6, leaving me with a simplified rational expression of x plus 2 over x minus 3. Looking on the right, well, we're going to run this gauntlet. Two numbers, first things first. Can I take something out on the top from all three terms? Nah. Can I take something out on the bottom from all three terms? Nah. So let's make this easy. What two numbers multiply to negative 30 and add to negative 7? That would be a positive negative combination where the negative is stronger. You run the gauntlet, x minus 10, x plus 3. Remember, it's a minus 10 and a positive 3. Okay, moving on to the bottom part. What two numbers multiply to negative 24 and add to negative 5? Well, that would be a stronger negative and a weaker positive. So you'd run the gauntlet, you'd make that table, and you'd end up with x plus 3, x minus 8. Is there anything else I can factor out? No. So let's figure this out. Can I cancel anything out? Yes. The x plus 3 cancels out with the x plus 3, leaving me with x minus 10 over x minus 8. Okay. I'm going to put all three of these up here. There'll be a 6, a 7, and an 8, and that'll be it. I'd ask how you guys are doing, but I'm just communicating with the voices in my head. Okay, let's do 6, 7, and 8. X squared minus 11x plus 18. X squared plus 2x minus 8. Put number 7 right here. X squared minus 8x plus 15 over x squared minus 9. X squared plus 3x minus 28 over x squared minus 49. Let me see if it all fits in the camera. I'm going to move it just a little bit to the right just in case. Okay, see if you can attempt these problems independently. All right, let's take a look at problem number 6. Well, can I take something out from all three of these? Nah. Can I take something out from all three of these? Nah. So I can't factor out a GCF on the top or bottom. So I got to get creative and factor a quadratic trinomial. What two numbers multiply to positive 18 and add to negative 11? Well, if they multiply to form a positive, they can either be positive positive or negative negative. In this case, a positive plus a positive would be a positive, so it has to be a negative times a negative because that would add up to more negative. You run the gauntlet, you find out the winning team is -2, -9. So the factored version is x minus 2, x minus 9. On the bottom, what multiplies to a -8 but adds to a positive 12? Well, that has to be a positive-negative combination, and the stronger of the two has to be a stronger positive. So let's make this stronger positive, weak negative. That has to be +4 and -2. X plus 4, x minus 2. Let me make that 4 a little bit neater. There we go. So, are there any factors that cancel out? X minus 2 over x minus 2, leaving me with x minus 9 over x plus 4. Okay. There we go. Actually, no. X plus 4. There we go. All right. Number 7. X squared minus 8x plus 15. Well, can I take something out from the top? Not from all three of them, no. Can I take something out from the bottom? No, but this is a special case. Straighten the tie, everybody, because that bottom part is a pair of conjugates that'll eventually get factored because they form the difference of two squares. So, what multiplies to positive 15 and adds to -8? That has to be -3 and -5. Well, on the bottom, we have the difference of two squares. Now, you could approach this as what multiplies to -9 and adds to 0, but you gotta know your conjugates. You gotta know your conjugates to get into calculus. So, for the sake of argument, x squared minus 3 squared, well, that can be factored into x plus 3, x minus 3. So, now we factor out the top and bottom. Is there anything that can cancel out? Yes. X minus 3 cancels out with x minus 3, leaving me with x minus 5 over x plus 3. Okay. And finally, the last problem. I'm going to shift it to the right so that you could, because I don't think the camera can fit all that. There we go. Okay, x squared plus 3x minus 28 over x squared minus 49. Ooh, we got some conjugates. So, can I take something out from all three terms? Nah, not a GCF. We have to factor a quadratic trinomial. What two numbers multiply to -28 and add to 3? Has to be a stronger positive. So this becomes strong positive, weak negative. Specifically, that combination is +7, -4. X plus 7, x minus 4. Then we look at the bottom. Is this the difference of two squares? Is this a subtraction problem with two squares? Yes. So this becomes x squared minus 7 squared, or we factor into conjugates. X plus 7, x minus 7. So, is there anything on the top and bottom that can cancel out? The answer is yes. X plus 7, they cancel out, leaving me with x minus 4 over x minus 7. All right. Hopefully you guys enjoyed that. I'll see you guys on Thursday.